while we're waiting for Mark, maybe we can go ahead and start talking about some of the TC cache size and host memory target issues. Naya, do you want to talk a little bit about those?
Yeah, sure. So the summary here is that we've been trying to compare performance across Nautilus and Pacific, especially for RGW workloads. And we've been using two different kind of workloads. One which focuses mostly on smaller objects. I think it's a distribution. So it's worth mentioning that the workload is CostBench, and the distribution of objects there for the smaller workload, smaller size workload is essentially like 1 KB objects to up to 256 KB at max. And there's a percentage involved there about how many or what size objects we are writing. And the other workload is a mix of small and big objects or ops in CostBench. So that to just like have a different workload profile from smaller objects. Now, essentially, what we noticed is that with smaller size workload, we are doing much better in Pacific in most scenarios. When I say most scenarios, it means we are doing write operations. We are doing tests that just do a fill workload, which is essentially a fill operation in CostBench. We also do a mix of read, write, that's called hybrid, but that also does better in Pacific. And there's also another workload that essentially does writes and deletes. So like 80% write and 20% delete. Even there, we've noticed that Pacific is doing much better. And this is all with a small size workload. But it turns out that in the other workload where we have a mix of larger objects as well, when I say larger objects, it's more like max is one gig or something. It's not the case. In most scenarios, Pacific is not doing as well as Nautilus. Now, having said all of this, we started digging into what has changed, or what kind of settings Pacific is using versus Nautilus. And we found a couple of very interesting things. One thing is about OSD memory target. So essentially in Pacific, it is a known thing that OSD memory target is not overridden by any of the deployment methods at the moment, specifically Ceph ADM. Ceph ADM currently doesn't have the ability to override OSD memory target. In general, we have this mechanism in Ceph Ansible. What it does is that it consumes the whole host memory and it multiplies it with a safety factor and then divides it by the number of OSDs on that host to provide OSD memory target for each OSD. But this kind of calculation doesn't happen for Ceph ADM. So it is expected that we use a static value of 4 gig in the Pacific deployments. But in Nautilus, the expectation was that this calculation should have happened. And according to the amount of memory on the host, we actually calculated it should have been somewhere around 7+ gigs. But turns out these experiments were running with 2.5 or 2.6 gigs, which is not even close to 4 gigs. So this seems like something wrong going on in the deployment mechanism, specifically in Ceph Ansible with the Nautilus experiments. So we decided not to rely on the results and we want to repeat those. But the other aspect that also came out while we were doing this investigation was maybe I can just add a couple of PRs that have come out as a result of that in the chat for everybody's information. So this was one from Sage and there is one from Adam. So essentially, there is an environment variable, a tcmalloc environment variable, which is called tcmalloc max total thread cache bytes. This is also an environment variable which we, at least in Nautilus, we were setting this for both the OSDs and the RGWs, and the expectation was that it was using this by default. So you don't have to either by means of the deployment mechanism, however we had, be it Ceph Ansible or whatever, was setting it when the cluster was deployed. But turns out that for 5.0, and we haven't had evidence that even for 4.2, and this is all in containers, this was set correctly. So these experiments, again, are, or even the results are not valid in my opinion, because the assumption was that the TC-malloc environment variables should have been set correctly for these experiments. So there have been a couple of PRs that have come out as a result of this. I'll give a brief summary, and then maybe Adam, he is on the call, he can talk about it. The idea is the one from Sage is trying to set this value on a global level for all cluster wide for all daemons by using Ceph ADM. And the one from Adam is trying to set this for the OSDs by means of using the priority cache manager. Essentially, the idea is that if there is an environment variable that is set, and there is also a Ceph config option that he's introducing, if that one is set as well, the Ceph config option will take precedence over the environment variable. Adam, do you want to talk more about it?
Yes, sure. I mean, there is not really much to talk about. It's very simple thing. I just digged out through a TC-malloc interface and found a variable API that sets internal variable that's the same that uses to control the size of thread cache. This is the one that is on init is taken. The value is taken from environment variable TC-malloc total shard cache bytes. Let me copy it just for reference into chat. And the same value can be changed programmatically, and it works. I mean, it can be changed and it's applied. And that has been done on OSD initialization right after configuration variables from global init are accessible. There is a simple code just to read an OSD memory thread cache variable and apply it to thread cache. That's pretty straightforward logic. There is no that's just it. And the name of the variable is currently like this because I modified it for OSD, so I made it this way. It could be possibly like exported to some more general naming, and it could be even applied as a part of global init. Then the same would apply for any client. But yeah, I wanted to do something that's correct, and extending, I guess, will be a part of a discussion.
Yep, agreed. I think we need to at least make sure that this variable is set appropriately, and then we can figure out what is the best way to set it across. So yeah, I think that's kind of the summary. So essentially with these two things, these two findings, those results or trends that I talked about earlier, kind of, at least the Nautilus ones where we are not even using 4 gig OSD memory target, stand void. So we are going to be repeating those tests, and once we have newer numbers, we will try to present it in a follow-up meeting here. Josh, anything you want to add?
I just wanted to mention I posted in the chat as well for the OSD memory target piece that has been implemented in master for Ceph ADM. So need to double check exactly if it's using like the same kind of safety factor of that Ansible was, but it is tuning that for master now. It hasn't been backported to a specific release yet, but that's at least implemented now.
Oh yeah, I missed that one. I think if it's not risky enough, we can probably backport it to Pacific as well, right?
Yeah, most likely. And I want to take a closer look as well. I think it might I'm not sure if it's not clear to me. I haven't looked at it too closely yet, whether it's on by default, which I think it probably should be, and whether the safety factors match up with the kind of Ceph Ansible. With respect to the tcmalloc thread cache, Adam, I think your fix is fantastic. I'm glad you found this API. I'm not sure if we want to apply it to absolutely everything, like including clients, but in global init, we do have the concept of an entity type where we differentiate between daemons and clients, so we could apply it just to daemons. Things like RGW initialize themselves as a daemon, I believe. Well, I guess we'd want to double check to confirm that. That certainly seems like a better long-term solution than trying to set environment variable everywhere.
But then the question would be if the same would apply to any daemon. Because if we want to pass different value to different daemons, then setting it up in the same place would be strange, at least.
Yeah, I guess we haven't. I'm not aware of any testing on daemons other than OSTs and RGW. Mark did some testing on RGW in the past week that showed. I don't think he tested the 128 megabytes, which is the value we're proposing to use by default here. But for RGWs, he was testing between like 32 megs, which is the default for tcmalloc, and 512 megs, which is much higher than our proposed value. And he did see a pretty dramatic performance improvement with that.
Well, I can extend that PR to give admin command to control it dynamically. tcmalloc seems to be handling it pretty okay.
Oh, it's dynamic.
I mean,
okay.
it takes some time to just drop the caches from maximum to current, but it works. But if it could be admin command, then we could dynamically even test what is the optimal solution for, I don't know, just at least test, because currently it's difficult.
Yeah, that'd be quite nice if we could enable that to be dynamic. If it could be a config value that's observed, and just changing that config value would change it within tcmalloc as well. That would be ideal, I think.
Okay, so I will modify.
Cool. That's much. Sounds like tcmalloc is much more flexible than I thought, so that's fantastic. Yeah, I think that's all I had for these findings. Are there other aspects that I think are worth discussing?
I think Mark is not here, but maybe next week he can talk about some of the RBD tests that he's been doing. But yeah, that can wait until next week.
Sure. Yeah, I guess the other topic Mark wanted to bring up was his testing on RGW and CPU usage, but since he's not around, I think we'll have to postpone that one as well. Are there any other topics folks would like to discuss this week? All right, you're hearing silence, so keep this short today, and see everybody next week. Thanks, folks.
Thank you.
Thank you, guys. The performance weekly without Mark is just not the same.
I'm sure I'd be happy to hear that.